Hello students, so we are plus 2 class and we have started D and F block elements. D block elements mean generally it starts from group 13 to 12. These 13 to 12 group is known as the D block elements. And here are the series, like 3D series is known as scandium to zinc, 4D is from zirconium to cadmium, and 5D is lanthanum to mercury. These are the elements which are present in that D block elements. Three series are there, main 3D, 4D and 5D. Next is the electronic configuration of these elements. Is generally is n-1 D 1 to 10, because in D we can fill maximum 10 electrons, and ns 1 to 2. n-1 before the D is written because it is inner D orbitals. That's why it is n-1. These are the inner D orbitals. And with S is also involved in the formation of a bonding, and in the electronic configuration electrons are present in D and S orbitals. And these D block elements are known as a transition elements. Why these are known as a transition elements? Because they have an incomplete filled D orbital. That's why it is inner D orbitals. Transition elements, these are known as a because they have an incomplete filled D orbital. But in this, the elements like zinc, cadmium, mercury is not known as a transition metal because they have a completely filled D orbital. The elements are zinc, cadmium and mercury. These are not known as a inner transition elements because they have a completely filled D orbital. Next, they are atomic and ionic radii. Atomic size, like addition of electron, that is in the D orbital in the same shell, that increase the effective nuclear charge, and due to increase in the effective nuclear charge the size decreases. So atomic size decreases. Why it decreases? Because addition of electron that adds the or that increase the effective nuclear charge on the atom. Next, like iron, cobalt, nickel, their size is almost same because in this case they are increase in the effective nuclear charge, but in the same way with the increase in effective nuclear charge there is a repulsion which cancel this effective nuclear charge. That repulsion is due to the shielding effect. Which cancel it, and that's why the iron, that cobalt and nickel, their size is almost same. Next, they are known as a lengthened contraction. Lengthened contraction means like filling of that 4F before 5D. 5D fill करने से पहले 4F is filled. Filling of 4F orbitals before 5D, that results in decrease in the size. That is known as a lengthened contraction. Filling of 4F before 5D is known as a lengthened contraction. Melting points, generally their interatomic bonding is high, and their high melting points due to this is also due to that n-1 D and ns1 to 2 electronic configuration, that also adds the increase in the melting points. Next is the ionization energy. As they have a more effective nuclear charge, their atomic size is small. It means their ionization energy is high because their effective nuclear charge is more, size is small, effective nuclear charge is more, and their ionization energy is also high. Chromium, copper, they are large ionization energies. Why they have a large ionization energy? Due to their neighbor elements, because they have a stability due to half filled electronic configuration. Their electronic configuration is exactly half filled. Those elements are chromium and copper. Their ionization energy is more as compared to their neighbor elements. Next is the oxidation state. Oxidation state is variable. It varies from +3 to +7. Means +3 is possible, +4, +5 and +6 or +7. Oxidation state is possible. Variable oxidation state. This is also due to the electronic configuration that inner D orbital is filled, and after that electrons are present in the S orbital. Next is the reactivity. Generally 3D series are more reactive than the elements of 4D and 5D series. And these formation of compounds of these transition metals, they form a large number of complexes. Their compound formation capacity is high. Why it is high? Because there are three reasons. First one is small in size, second is the high ionic charge, and third one is the availability of vacant D orbital. Vacant D orbital is available because electronic configuration is D n-1 D 1 to 10 and ns 1 to 2. Due to this electronic configuration, these transition elements are more reactive and the compound formation is capacity is high. These reasons are small in size, high ionic charge, and availability of vacant d orbital. That's why they form a number of complex compounds. Rest we will discuss in the next session. Thank you.